chemistry of it. The question pertaining to orbital overlap, sigma and pi bonding, which type of orbitals overlap occur in cumulene? So the first thing we need to do is, when we look at cumulene, figure out what orbitals we're using. So what's the hybridization of everything involved? So when we look at the structure, right, hydrogen only has one orbital that it can use, and that's the s orbital. So hydrogen, s, s. Hydrogen, right, does not have to hybridize to bond, so these are just all s orbitals. These two carbons, the first carbon and the last carbon, they have 1, 2, 3 electron domains, 1, 2, 3 electron domains. So as a result, we'll call this carbon 1, carbon 2, carbon 3, and carbon 4. Carbon 1 and carbon 4 are sp2 because they have 3 domains. And then carbon 2 and carbon 3, carbon 2 has 1, 2 domains, and carbon 3 has 1 and 2 domains. So carbon 2 and carbon 3 are both sp hybridized because they only need 2 electron domains. So to make 2 hybrid orbitals, we would mix an s orbital with a p orbital. For C1 and C4, we need 3 domains, so we need 3 hybrid orbitals, so we would mix 1 s orbital with 2 different p orbitals. And the second part of the question was asking, what orbital overlap would occur. So for the sigma bonds, right, starting left to right, for our sigma bonds, we would have the s orbital on hydrogen overlapping with the sp2 hybrid orbital on carbon 1. And then carbon 1 to carbon 2, that would be carbon 1 is sp2, and that would be overlapping with an sp orbital on carbon 2. Carbon 2 and carbon 3 would be overlapping with sp and sp orbital. Sp orbital from carbon 2 to the sp orbital of carbon 3. And then carbon 3 would just repeat the same bonding it would that carbon 2 does. It would also have overlap. The sp orbital of carbon 3 would overlap with the sp2 orbital of carbon 4. And this is where most people are getting the question wrong because they think, okay, I've accounted for all the bonds in this structure and there's no other bonding I have to consider. Well, that's not true because you've only accounted for the sigma bonds only. Next, we have to think about the pi bonds, right? So pi bonds can only form from the side-to-side orbital overlap of 2 atomic p orbitals. So to form this pi bond between this carbon and this carbon, or this pi bond or this pi bond, right, we need to have that side-to-side orbital overlap of 2 atomic p orbitals. And so C1 is sp2, so that means there's 1 p orbital here. C2 is sp, so that means it has 2 unhybridized p orbitals. I'll just draw one for the sake of demonstration that, right, here's that pi bond, the p orbital of C1, the p orbital of C2, side-to-side orbital overlap above and below the plane of the board. And we'd see the same bonding here between C3 and C4. Orbital overlap above and below. And then I'll try to do the other p orbital here. So on C2 and C3, the other p orbital would be kind of going into the board or into the page and coming out of the page, and we'd have orbital overlap in front and behind. So we have 2 different p orbitals overlapping, or 2 different p orbitals involved in bonding with C2 and C3. So these should be all the possible combinations you'd expect to see orbital overlap with this structure of cumulene.